Okay, good morning everyone. This is Miss Triangle. We are now on section 11.3, the area of polygons. So our essential question, our EQ, is how can you find the area of a regular polygon? Our learning target 11C is I can find the area of a kite, a rhombus, or a regular polygon. So how do you find the area? We're going to start with a rhombus or a kite. They actually share the same formula. The area of a rhombus or a kite with the diagonals D1 and D2 stands for diagonals. The area is, that's not written super well, area equals 1/2 times the first diagonal times the second diagonal. And that is the same formula for both a kite and a rhombus. Pretty straightforward. You just want to make sure diagonal, that is a diagonal. It goes from one vertex across to the other. And here is another diagonal like that. Okay, then, and again, the nice thing about this is you can always pause, and there's a lot of information on here. You don't necessarily need to write everything. So what should you be writing? Let's look at it. The diagram shows a regular polygon, so you definitely want to know something about what a regular polygon is. So regular, what does that mean? I would write this, all sides, that's all by the way, all sides are congruent. If you want to use the math symbol for congruent, all sides are congruent. So what we mean by that is, let's say you have a pentagon or something like that, they're all equal. Like maybe 2, 2, 2, 2, 2. All right, that is a regular polygon. All equal sides. So the diagram shows over here, here's your diagram. The center of a regular polygon, so P is the center. Maybe I'll make that red for you. That's pretty straightforward, the center. Then you want to make sure you're understanding what a radius is and what an apothem is. So the radius of a polygon, the center of a polygon and the radius of a polygon are the center and the radius of its circle. The distance from the center to any side is called the apothem. So the apothem, you definitely want to know what an apothem is. Apothem is this blue line from point P to Q. So it goes from the center to the opposite side. So I'm going to move this over a little bit. Maybe you want to write apothem. Okay, it goes from center to the opposite side. So not to the vertices like M and N. It goes from P to Q to the opposite side, and it is perpendicular. So it's forming a right angle, and it creates two isosceles. I don't know if I spelled that right. Two isosceles triangles. And more about those two isosceles triangles and how that can be useful in solving problems will come up on example 3, possibly example 4, but the apothem is this blue line PQ in the diagram. PQ is my apothem. So it goes from the center to the opposite side. It is perpendicular, making a right angle, and it creates two isosceles triangles. All right, the radius, you don't want to be confused about the radius. The radius, and PN is a radius, that goes from the center, from point B, so from center to a vertex. So there are two radii, PN is a radii, PM is a radii. I mean, I could draw other ones over here. These are all also radii as well. Okay, so that's what a radii is versus a apothem. The other thing that you need to know is a central angle. So a central angle is an angle that is created by two radii. So right here it's telling you, maybe I'll circle in green, angle MPN. MPN, this big angle, that's the central angle. So it's two radiuses or radii. So you find that by doing 360 divided by the number of sides, or 360 divided by n. So that is also something that you need to know. So make sure You take your time and pause if you need to for that information. I tried to summarize the key points. The last thing down here is the area of a regular polygon. Remember, regular would be congruent sides. So it's 1/2 A times P. That's usually what I use, that first one. Just remember that A is apothem. Okay, A is apothem. And P is perimeter. So it's not one side, it's perimeter. They gave you this other formula right here. And instead of using perimeter, they said the number of sides times the side length. Well, that is how you find the perimeter. So if you want to write down both, or that one if you think that's easier, you are more than welcome to do so. All right, let's get into some of the examples. So example 1, we have it says find the area of each kite or rhombus. So for kite and rhombus, I'm using my area equals 1/2 D1 times D2 formula. So these ones are pretty straightforward. I'm just going to plug in my numbers. D1 and D2, the order does not matter since you're multiplying. So I can say 8 times 6 or 6 times 8. They're both 48. Remember to take half or divide by 2. So 24 meters squared. For part B, maybe pause, see if you can get it on your own, and we can compare what answers you got. All right, so hopefully you are getting 35, half of 70, 35 square centimeters. So that's how you use that formula. A few of the homework problems might have you working backwards, like putting something in for A and solving. But if you need help with that, you can always reach out to me. All right, number 2. In the diagram, ABCDE is a regular pentagon inscribed in circle F. Find each angle measure. Part A, find the measure of angle AFB. So let's kind of trace that. AFB is my central angle, So to find a central angle, I do 360, so that's my central angle. So you do 360 divided by the number of sides. It is a pentagon, 5 sides. 360 divided by 5, that angle is 72 degrees. All right, next, angle A. I'm going to erase this so I can see a little better. Find the measure of angle AFG. So that is half of my central angle. And the apothem cuts it into 2 congruent isosceles triangles. So I can take my central angle from part A, 72, that's where that comes from. And now I'm cutting it in half. I divide by 2, and AFG is 36 degrees. All right, for C, we are looking for angle GAF. So I'm going to actually just draw part of this triangle here. So here is G. Here is my center at F, and here is A. So let's think about, we are trying to find GAF. So we are trying to find X. I'll put that right there, GAF. Okay, we do know from part B that angle AFG right here, AFG, we know that that is 36 degrees. We found that in part B by taking half of 72. We know every triangle has 180 degrees. So we can do 180 minus 90 minus 36, or you could even just do 90 minus 36, save yourself a little bit of work, and we get 54 degrees.